We all have a gut feeling for what complexity means, right? It's that sense of um, many interconnected pieces where cause and effect get tangled up.
Yeah, definitely. But when you try to really nail down a definition, scientifically or philosophically, it can feel like grasping smoke. It resists easy answers.
It really does. We see it everywhere, don't we? From tiny cells interacting to, I don't know, global economics.
Exactly.
And that brings us to a fascinating source one of you sent in, Luiz von Paumgarten's The Abstractionists papers. Now, these aren't your typical academic papers. They offer a genuinely fresh and I think remarkably comprehensive way to think about complexity.
They really do. It's quite a unique perspective.
So the mission for this deep dive is pretty straightforward. We're going to unpack what complexity really means according to these papers, how it works, what makes this view new compared to other ideas, and, well, why it should matter to you.
It's a good goal. And the papers introduce some really compelling concepts we'll need to dig into, things like the red space and the blue space.
Right.
The really critical role of something called the blindfold, this idea of unseen causal spaces operating with their own rules.
Hmm.
We'll look at examples too, like the game of life, maybe the three-body problem, even something like an ant bridge.
Okay, yeah. And these core ideas, red and blue. Red for our subjective experience, our models of the world, and blue for the underlying interactions.
That's the gist of it, conceptually.
Hmm.
They're tools to think with. So yeah, let's get into it.
Okay, so according to the Abstractionist papers, fundamentally, what is complexity? Lay the groundwork for us.
Okay. The foundational idea rests on two aspects of reality. They're distinct, operate kind of independently, but they're deeply connected, like two sides of a coin.
Okay.
First, there's the interpretive domain. That's what the papers call the red space.
Yeah.
This is basically your individual mental model of the world, your thoughts, feelings, perceptions, memories,
Yeah.
your unique internal reality.
All right, my red space, my personal lens on everything. So what's the other side?
The other side is the causation domain, or the blue space. This is the shared reality of interacting processes, the underlying mechanics of how things actually work, how they influence each other. The papers argue that complexity really emerges from the continuous interplay, the sort of dynamic relationship between these two domains.
So my experience, my red space, it isn't a direct feed from this shared reality, this blue space. There's some kind of translation happening.
Exactly. Your red space isn't a mirror of the blue space. It's an internal construction. Your mind builds it based on interpreting signals that originate in the causation domain.
Okay.
And here's where it gets really interesting. The papers talk about this blindfold. We don't have direct awareness of this construction process itself. We just experience our red space as reality, often totally unaware of the causal dance and the blue space that's actually generating it.
The blindfold, that's a powerful image. It really highlights our inherent limits in perception, doesn't it?
It does.
So how does complexity actually emerge then from this interaction between our interpretations and these underlying causal processes? What's the mechanism driving it?
The mechanism described is this process called general selection. Think of it like evolution, but much broader, operating on any interacting process, not just biology.
Okay, like evolution on steroids?
Sort of, yeah. It's this continuous recursive loop that happens in both the red and blue spaces. Processes interact, that creates variations. Some variations get selected, meaning they persist or get reinforced, and these selected changes accumulate, influencing what happens next.
General selection. It sounds a bit like Darwin's natural selection. Is it basically the same idea?
It shares core ideas, for sure, but the scope is way broader. Darwin focused on biology. General selection in this framework applies to almost anything: how technology develops, cultural shifts, even how our own thoughts form and stick. It's framed as a more universal principle for how complex systems change and adapt.
Interesting. So it's not just biological. Okay, so variations get selected, they accumulate, things change. But what about those really big leaps? When a system jumps to a totally new level of complexity, what drives those major shifts?
Right, good question. The papers introduce incoherence as a key driver for that kind of transformative change, for real emergence. This isn't just a bigger change, it's like changing the rules of the game itself. You get properties you absolutely couldn't predict from the old rules.
Okay.
Incoherence is when a process basically steps outside the limits of its current causal space. The analogy they use is pretty vivid. Imagine stepping off the train tracks entirely, not just trying to build a faster train on the same track.
Stepping off the track. Okay, I get that. A fundamental redefinition, not just making the old way better.
Precisely. And this often involves moving between what the papers call unseen causal spaces. These are like conceptual domains defined by their own distinct governing rules. Emergence often happens when a process shifts from playing by one set of rules to another. Think about water turning into ice. The H2O molecules are the same, but they're suddenly operating in a different causal space, governed by the rules of solid-state physics.
Okay, that makes sense. This whole perspective, it feels quite different from how we often think about reality. How does it stack up against more, let's say, conventional views in science or philosophy?
That's a crucial point. Think about classic metaphors like Plato's cave or even the Matrix. They generally suggest there's one shared illusion we're all stuck in, right? And one ultimate truth outside it.
Yeah, the prisoners seeing shadows, Neo waking up to the real world.
Exactly. But this framework from the Abstractionist papers goes in a different direction. Instead of one shared illusion, it talks about parallel individual interpretations. Your red space, my red space, existing alongside a shared causal reality, the blue space, that we only perceive indirectly. There isn't just one cave wall or one matrix. There are countless individual red veils, as the papers call them.
That is a fundamental shift. Wow. What about cause and effect? How does that compare? We usually think pretty linearly. A causes B causes C.
Yeah, traditional models are often linear. This framework presents causality as more like a web of readiness and response. It's less about A directly causing B, and more about one process creating the conditions, the readiness, for another process to respond, which then becomes a new cause.
A web.
It involves things like induction and also something called causal impedance. Think of causal impedance as like the resistance a system has to change. How easily does an effect spread through it? Some systems are stiffer, harder to change than others. These things shape how changes ripple through in between those different causal spaces.
Okay. And what about those big philosophical ideas? Subjective versus objective reality. Where do they fit in this red and blue picture?
Well, interestingly, both find a place. Your subjective experience, your feelings, your qualia, that's firmly in your red space. The blue space, the domain of interactions, represents a shared reality that exists whether you interpret it or not. You access it indirectly, though, so it's not about one being more real. They're just different domains with different logics.
Okay, I'm starting to see how this is distinct, but what's really novel about it? What new insights does it give us?
I think one of the biggest novelties is really nailing down this sharp distinction between causation and interpretation. The papers argue this boundary hasn't been drawn quite this clearly before. We talk about subjective, objective, physical, abstract, but separating the doing from the experiencing of the doing, that specific line offers a really powerful lens for complexity.
And how does drawing that line help? What new tools or understanding does it provide?
Well, for one thing, it gives us tools to understand paradoxes, maybe even resolve some of them, things like the chicken and the egg or the ship of Theseus. These often pop up when our internal logic, our red space interpretation, bumps up against the messy reality of causal processes in the blue space.
How so?
By seeing the different logics at play, the looping coemergence in the blue space versus our linear expectation in the red space for the chicken egg, for example, the paradox can kind of dissolve. It rises from applying one domain's logic to the other inappropriately.
That's a really neat way to think about those old puzzles. Are there other, maybe more practical applications?
Oh, absolutely. The framework offers insights into all sorts of real-world systems. Think about learning. It's not just soaking up info, right? It's a causal process. Your mind engages with signals, adjusts its internal model, refines expectations. That's red and blue interacting. Or market dynamics, you can see interacting causal spaces. Supply and demand follow certain rules. Consumer psychology follows others. They bump into each other. Even tech evolution, it's like general selection happening across different technological and social causal spaces.
So understanding these red and blue spaces and this biological blindfold, our limited direct view of the causal stuff, it helps us navigate the world better.
Exactly. Realizing our experience is a construction and that other people have their own valid constructions, their own red spaces, based on maybe different interactions. It can lead to more nuanced communication, maybe more empathy, less getting stuck in our own viewpoint. It pushes you to ask how things work causally, not just why you interpret them a certain way.
Okay, this is incredibly thought-provoking conceptually. Can we make it more concrete? You mentioned examples earlier. The game of life, the three-body problem, the ant bridge. How do they illustrate all this?
Yeah, great idea. These are perfect for seeing it in action. Let's start with Conway's game of life. You know it. Simple rules for cells on a grid. Live, die, born based just on their immediate neighbors.
Yeah, simple rules, but you get these amazing complex patterns moving around, gliders and things. They look alive.
Exactly. That's a perfect illustration of complex emergent behavior popping out of simple local interactions in the causation domain. The grid and rules are the blue space here. The gliders aren't programmed in, they just emerge from repeating those simple rules.
Hmm.
And you see general selection, too. Those
Yeah.
stable patterns like gliders are selected because they persist within the game's rules.
Okay, yeah, I can see the blue space interaction leading to emergent forms there. What about the three-body problem? That always sounded just messy.
It is messy. So you've got three objects interacting gravitationally. Unlike the nice, predictable orbits you get with two bodies, the paths of three bodies can become seemingly chaotic, totally unpredictable over time, even though they're strictly following Newton's laws.
So deterministic rules, but unpredictable results.
Right. It shows complexity emerging from dynamic interactions within a single causal space, the space defined by Newtonian gravity. The constant push and pull between the three bodies just creates this incredibly intricate dance that's hard to predict long term.
So even with clear rules, just the interconnectedness itself breeds complexity.
Absolutely. And then look at the ant bridge. It's fascinating. Certain ants encounter a gap, and they link their bodies together to form a living bridge for others to cross.
Without a foreman ant telling them what to do?
Exactly. No central plan, no blueprint. This complex structure emerges purely from simple, local interactions. Each ant just reacts to the ants right next to it, grabbing on based on simple rules. It's a beautiful example of emergence in the causation domain, a complex global result from simple local rules and interactions.
Wow. So each ant is just following its basic program, but together they create something much bigger and more functional.
Precisely. And this loops us back to red and blue. Remember, red is our subjective experience, or our models like our understanding of gravity or ant behavior. Blue is the underlying network of interactions, the actual forces, the ants bumping into each other existing independently. Complexity, like these examples, emerges from that constant interplay between the two. Our red space tries to make sense of the blue space, often with simplified models that capture some, but not all, of the richness.
Okay, let's start to wrap this deep dive up. What are the really crucial takeaways about complexity we've pulled from the Abstractionists' papers?
I think the core insight is this dynamic dance between two distinct but connected domains, the interpretative red space and the causational blue space. Recognizing that blindfolder, our lack of direct access to how our own minds construct reality, that's fundamental. Then there's general selection as the engine of change interaction, variation, selection, accumulation operating everywhere, and incoherence as the driver of truly transformative leaps, stepping outside the current rules. And finally, rethinking causation not as a simple chain, but this complex web of readiness and response happening across different spaces with different rules shaped by things like causal impedance.
And this isn't just for understanding physics or biology, is it?
Absolutely not. That's the exciting part. This framework offers a new lens for understanding us, human thought, behavior, society. By seeing that split between interpretation and causation, we can get deeper insights into everything from how we learn personally, to how markets work, to how ideas and technologies evolve.
So for you listening, here's a final thought. Take a complex system in your own life or your field. Think about it through this lens. How might seeing the red and blue spaces, the causal impedance, the resistance to change, maybe the potential for incoherence, how might that give you new insights, new ways to understand or maybe even act?
Yeah, it encourages asking not just why from our perspective, but how things became causally possible. If this has sparked your interest and you want to go deeper, you can find Luiz von Paumgarten's The Abstractionist papers online for free. Just search for welcometothe bluespace.com. It might genuinely offer a new way to see the complexity all around us.